Okay, this is the last video in this unit, and it deals with finding the derivative of our natural log function. So the derivative of the natural log function is 1 over the function itself with the chain rule here being applied. Okay, so what you have to understand is that in many of these problems, our log properties from a prior course are going to come into play, and they're going to make your life a lot easier when it comes to finding the derivative. So always be on the lookout for these log properties. As a review, they are the log of a product, call it A times B, that's equal to the log of A plus the log of B. Likewise, recall that the log of A divided by B is the log of A minus the log of B. And finally, if we have the log of A raised to some power, call it n, we can take that power of n and throw it down in front and multiply it by the log of A. So let's take a look at some examples, and for some of these we're going to do them a couple different ways. So the first one, if we use our rule for the derivative of the natural log function, we would have 1 over whatever the inside function is, which is x to the 5th, and then we're going to chain along the derivative of x to the 5th, which is 5x to the 4th. So if we clean this up, it's 5x to the 4th all over x to the 5th, which if you simplify it further, you'd be left with 5 over x for your final answer. Now, let's do it another way, but this time let's use a log property. We know if we're talking about y equals the natural log of x to the 5th, this is the same as taking that 5, throwing it down in front, and multiplying by the natural log of x. Well, if I now jump to my derivative, the 5 comes along for the ride. The derivative of ln of x is 1 over x. Technically, we're chaining along a 1, which is the derivative of x. Okay, notice how when we use a log property, it's a lot easier to get the same answer. Okay. Second one here, there's no log property that we can do. Please make a note, if you need to, that you cannot distribute an ln to these three terms. Instead, all we can do is to do 1 over the inside function, so 3x squared minus 5x plus 8, and then we multiply by the derivative of that inside function. That's what we call the chain rule. So 6x minus 5, and then I'm just going to slide that over. And that's all we can do with it. That's our final answer. So again, write yourself a little note by number 2 here that you cannot distribute that ln to the three terms. That's not one of our log rules. Alright, number 3. This is the same as the natural log of x to the 1/2 power, right? So from here, let's use a log property. This is the same as 1/2 ln of x. So now we're ready for our derivative, y prime. So it would just be 1/2 times 1 over x. Because again, the derivative of the natural log of x is just 1 over x. So this is 1 over 2x. Okay? Alright, number 4. We want to compare this to number 1. Notice that in number 4, the entire quantity is raised to a power of 5. So what that suggests is that we cannot use a log property. Look at the difference here. With number 1, you have the natural log of x to the power of 5. So we were able to put that 5 in front. But with this one, the whole quantity is raised to a power of 5. So you cannot use a log property. So instead, what we're going to do is we're going to use our chain rule. We're going to first find the derivative of the outer function using the power rule. So that 5 would be dropped down in front. ln of x on the inside comes along for the ride. The new power is 4. And then we have to chain along the derivative of the inside, which would be 1 over x. Okay? So we can clean this up slightly by just doing 5 over x times ln of x to the 4th. Okay, let's go on to our next page. Alright, so in our next example here, notice we have a product. We have a product of two functions. So we need our product rule. So, drop my paper here. Hang on a second. Alright, so, oops. Let's go right to our product rule. The derivative of x squared is 2x times, keep ln of x the same, plus, now keep x squared the same, and then the derivative of the natural log of x, we know is just 1 over x. So, from there, there's a little bit of simplifying we can do. This second term here becomes, if we were to divide an x out, you're just left with x. So you have 2x ln of x plus x left for your final answer. And if this were a multiple choice question, it's possible they may have you take out an x as a GCF. This is one big term, okay? So if we take an x out of it, you're left with 2 ln of x plus 1. Alright, so it is possible that, again, if it's multiple choice, you might have to take it that far. Number 6, we need our quotient rule. Okay, so write yourself a little note if you need to. So low, d high would be 1 over x. Low d high minus high d low. Well, the derivative of down low would just be 1 all over low squared. Well, from here, that first term will simplify to just 1, and then minus ln of x all over x squared. Okay? Alright, number 7 here, I wanted you to compare it to number 3. And number 3, if you recall, let me just jot this down, number 3 was ln of radical x. So this is different. Back with number 3, we were able to use a log property. Alright, but here, this is the same as the natural log of x raised to the 1/2 power. So we're going to have to, just like we did with a similar example earlier, you have that whole quantity raised up to a power. We need to use our chain rule, which says to multiply that down. Alright, we're really doing the power rule on the outer function. Alright, so then we have a negative 1/2 for our new power, and then we're chaining along the derivative of the inside, which is 1 over x. So if we clean this up a bit, we can write this as 1 over 2x times, and we could change this to 1 over the square root of ln of x if we wanted to get rid of the negative power and rewrite it as a radical, getting rid of the fraction as well. So this is one possibility for your answer. Okay? Again, if it's multiple choice, that's what you're likely to see. Next one here, a little more complicated. We have the natural log of the natural log of x. So what you have to keep in mind here is that you have an inner and an outer function. The inner function is ln of x, and then we have another ln on the outside. So we have to do our derivative of the outer function. Just like we did in the previous problem, the derivative of the outer function in number 7 required us to use the power rule. Well, here, the derivative of the outer function, which is ln, the derivative of that would be 1 over the inner function. So it would be 1 over ln of x, and then we have to chain along the derivative of this inside, which would be 1 over x, because that's the derivative of ln of x. So 1 over x, actually let's do this as one big fraction. So we would have 1 over x ln of x for our final answer there. Okay. All right, number 9 here. Again, you cannot distribute an ln. Okay, so this would just be, for our derivative, 1 over this inside piece comes along for the ride, and then we have to chain along, which means we're multiplying by the derivative of the inside. All right, this inside is this piece right here. So 1 plus e to the x. So we can simplify this. We can write this as 1 plus e to the x all over x plus e to the x. Okay, do not be tempted to cancel those e to the x's. You can't do that. Okay, that's as far as we can take that. All right, 2 more. So with this one, get rid of that radical. Replace it with the natural log of x squared plus 2x. Now this is raised to a 1/2 power. Alright, it's not the entire quantity raised to the 1/2 power, so we could actually use a log property here to help us simplify this. So this is equal to 1/2 ln of x squared plus 2x. So again, this is not a derivative yet. I'm just rewriting this using some log properties. So now I'm ready for my derivative. So that 1/2 in front comes along for the ride. The derivative of the natural log of something is 1 over that something, so x squared plus 2x. And then I have to chain along the derivative of this bottom, which is 2x plus 2. So I can rewrite this as 2x plus 2 all over 2 times x squared plus 2x. Okay? And if you want, you could actually factor out a 2. And you're left with x plus 1 all over 2 times x squared plus 2x. And then you could divide out these 2's. So if it's multiple choice, perhaps you see this as your final answer. Okay? Last one, you're going to see that we have a lot of log properties here to use. We have the natural log of a quotient. So here we can turn this into the natural log of x squared minus the natural log of 3x minus 2. And we could take this a step further. I could take this power of 2 and throw it in front as 2 ln of x minus ln of 3x minus 2. So I just used a log property, and this is still equal to y. I haven't done a derivative yet. So now I'm ready for my derivative, y prime. So my first term would be 2 times 1 over x. Again, this 2 comes along for the ride. The derivative of ln of x is just 1 over x. Minus, we need the derivative of ln of that quantity, so that's going to be 1 over that quantity of 3x minus 2 with a 3 chained along. So let's rewrite this final answer as 2 over x minus 3 over 3x minus 2. And that's as far as you would take it. Okay, bye-bye.